All right. So integration by parts. Integral of u dv is equal to u times v minus the integral of v du. Okay, let me try to get in the right angle here. Okay, so let me give you a hint. So you use this guy when you have something you can't substitute and you have a product of two things that are just a pain in the ass. You can't figure it out. So let me give you a hint first as to how to use this. So choose, just check it out. Well, no, here, let me write it. Choose dv to be easily integratable. Because you get to choose which one is u and which one is dv, because the question will start here, right? This left-hand side. And you need to determine, okay, which one should be u and dv, because the way the formula works, you're going to take derivatives of u and integrals of dv. So if you pick a dv that's hard to integrate, then you probably want to reconsider. Same with u. You choose a u that is easily differentiable. Okay. So for example, let's say you have something like this, x times the integral of x times e to the x dx. So there is no u side that's going to help you here. There's no trig substitution or whatever, inverse trig. So you're going to choose, right? You choose the u. So the other one has to be dv. So then, to find v, you need to integrate this. So an integral of dv is equal to v. So integral of ex dx would be ex. So v is the same deal, right? That's how I want you to think about it. You pick a dv and you integrate and find v. If you cannot integrate this dv, then you should pick something else. Derivative of u will give me the du, which is dx in this case. Because I need the du, I need the v. I already have the u, but I need the v here too. You see how you need to find those missing pieces to use the formula. Okay. So apply the formula. And we're not going to worry about the c's, right? I know some of you are wondering, where's the c though? Right? We will do that at the very end. We'll tack on the c. And so apply the formula. So the integral of x e to the x dx will be equal to u times v, right? This is the formula. Since I chose them to be this way, it'll be x times v, minus the integral of v du, which will become x e to the x minus e to the x plus c. So that's how you deal with these kinds of problems. This is a new integration technique, right?
Is that after the integral is e to the x dx?
Yes.
Okay.
Is there any question on how this technique works?
This is for substitution, right? You picking the.
You choose the u and you choose the dv. We're applying a formula and integrating by parts. That's what it's called. But it looks kind of similar, like substitution, but it's different. X squared. Oh, hold on a second. X squared times ln x dx. What do you guys should think? What do you guys think should be dv and u? Because this is the first left-hand side, right? What's u? What's dv?
U equals x squared.
If we pick u to be x squared, then the other one has to be ln. It has to be dv, right?
Yeah.
But notice, integrating ln x is very difficult. So this is probably not a good choice because I don't want to integrate this, and neither do you. So whenever you run into something like this, and you're like, you know what, I don't know how to do this. I don't know how to integrate. Then switch it. Okay. This will be ln x because that derivative is easy, right? What is derivative of ln x?
1 over x.
Yeah, right? 1 over x dx. So this guy is x squared. Integral of x squared will be.
Can you move it up, please?
Yeah. So integrate this one, right? And that'll be 3 over 3. Yeah. You guys okay on that setup? Do you see why
Yes.
we chose it this way?
Yes.
Okay. Because once you do that, we just follow a formula. Okay. So the integral of x squared ln x dx is equal to u times v, which is this and that, x cubed over 3 ln x minus the integral of v du. And this doesn't seem too bad, right? So that'll be x cubed over 3 ln x minus the integral of x squared over 3 dx. So this answer will be x cubed over 3 minus x cubed over 9 plus c. So we were able to take care of this integral. Is there any questions on the second example?
Why did we go back to a x squared? This is from the beginning, the du. Okay,
Oh,
I see
right
it.
here? These reduce each other here.
I see it.
Okay.
Oh,
Now, let's try, let me teach you a shortcut. So far, well, before we do that, does the biparts formula make sense to everybody? Is there anything weird about how we applied it? Before I show you a shortcut.
Isn't it x3/3 so that when you integrate it, it would be x4/12?
Let's see here. Let's double check. To integrate this guy, we get 3/3. We get here, but these reduce it, right?
Ah, I see. Okay.
So 3, 3. Yeah, that's good. So thanks for double checking. You never know. All right. Okay, so there's this thing called a tabular method that basically makes this a shortcut. So when you have like high powers that are going to keep on repeating forever, you want to use this formula. Okay, like for example, the integral of x squared sine x dx. It's actually going to repeat itself over and over again. So what I recommend is using the tabular method. But first, let's choose. Oh, maybe we could do it both ways. Yeah, let's do it both ways so you can see the difference. Okay, what do you think is a good u?
The du to be, the dv to be x squared and the u to be sine x.
In this case, you can integrate both without any problems, right?
we'll use the sine x as a u and the du as a square, x squared.
The only thing is, do you see how if I pick u to be x squared, every time I take a derivative, it'll start to reduce, right? After 3 derivatives, this will be gone. But I can take derivatives of sine forever. It will never be gone. So I want this to be u because I know eventually it will disappear. Because if I switch it the other way, it'll repeat forever, which might work, but you might have to get clever. And I think the easy route is always the best route. What's integral of cosine of sine?
Negative cosine of
Negative
x?
cosine. Yeah, that's right. Okay, so let's try it out. So the integral of x squared sine x dx is equal to u times v, so negative x squared cosine x, minus the integral of v du, so negative cosine x times 2x. I'll put the 2x in front. Forgot my dx. You see how we still have 1 x power left? So we're going to have to repeat this again. So one more time, looking at this integral, u will be 2x dv will be cosine x. V will be something. du will be 2. What is the integral of cosine?
Sine x.
Sine x. That's right. Don't forget dx. So we're right. I'm going to rewrite this piece just so I don't confuse myself. This will equal. I'm going to put it down here. I don't know if I have enough space. So that'll be plus 2x sine x minus, excuse me, minus v du, which will be the integral of sine 2 sine x dx. Now we can integrate that, no problem, right? So this will be negative x squared cosine x plus 2x sine x minus integral of sine will be negative cosine, right? So 2 cosine x plus c. Any questions on any of these steps? Okay. Double check my stuff here. Yeah, that's right. All right, so this is the regular method. So now let's do the tabular. This is how tabular works. So first write the alternate signs. And you write the u and its derivatives. And then you write dv and its integrals or antiderivatives. Integrals. So at the beginning we chose u to be this, right?
Raise it up, please.
Shoot, I wrote it weird. Hang on, it's gonna bother me. Hold on a second. All right, u and its derivatives. dv and its integrals. Okay, so you start with plus, minus, plus. You start with the original u, and you take derivatives until it disappears. You start with the original dv, and you take integrals until you match all the way till the 0. So the integral of sine we said was negative cosine. Integral of this guy is a sine. Integral of this, oops, sorry, that's a negative. Yeah. Yeah. Okay. This is how the method works, right? So the positive sign will be attached to the product of x squared times this guy. Then you go this way, do the product of this one, the negative sign, times the next one, negative sign. Then you do a plus, and you do this guy. And we're done. And of course, the negative would be 0, but we're not going to worry about that because it's 0. So the answer to the original question using tabular method is going to be this first one, x squared, negative cosine, so negative, right? X squared times negative cosine, minus 2x times negative sine, so that would be plus 2x sine, positive 2 times cosine. Now I'm done. Right? See how this method is a lot faster, right? It will always be this way, this pattern. You have any questions on how that works?
So when it's zero is plus C then on this method.
Sorry?
When we zero out, that would give us our plus C, right?
No, 0 just tells us to stop. The C, we just have to remember to tack it on because it's supposed to be there.
Okay, that's because we're just doing.
Yeah, so just remember at the end of all these questions, put your C. Because if you do it along the way, you just have to rename the C over and over again.
Okay.
Because technically, we should have a C1 there, and then another C2 here, and then another C3 there. C1 plus C2 plus C3, let's call it C. We'd end up with C anyway. So the easiest way to think about it is just to add it at the end and don't worry about it. Because C's technically appear multiple times along the way, right? Because I did what? 1, 2, 3 integrals here. So there's technically 3 C's, right? But let's not worry about it. All right, let's do one more. Okay. Okay, so let's use the other method because once we learn it, it's going to be easy, right? So we know we should stick with plus, minus, plus, minus. I don't know how many you need, but I'm going to pick, and remember, you can use tabular method with any of these questions, but I like using it when I see a power that needs to disappear and a function that will not disappear. So I'm going to put the derivatives right here. Integrals over here. So what is the integral of sine 4x? 1/4, right? Negative cosine 4x. Yeah. And then again, right? another integral. That would be still negative 1/16 sine 4x. Another one, positive 1/64 cosine 4x. So let me show you how I did that, in case you're wondering, why didn't I do U sub, right? Because I've done U sub so many times that you see a pattern. When you see a number here, the derivative or antiderivative will always be negative cosine 4x, or sorry, kx. Let me write that better. I did the 4 again. Sorry guys, it's distracted today. K for any number K. So I figured if it's going to keep happening, right? So the RK was 4, so I put a 4 down here, and then we do it again, another 4, 16, another 4, 64. So you have a pattern just over and over again. Okay? So then we go like this. Okay, so the answer will be the integral of x squared sine 4x dx will be negative x squared over 4, right? Multiplying these right here. The first arrow, cosine 4x minus times a minus will be plus 2x over 16 sine 4x plus, okay, so plus 2 over 64 cosine 4x plus c. So all of this came from these arrows. And we can reduce this to get 2 over 16, that is an x over 8, sine 4x, 2 over 64 is a 1 over 32, cosine 4x plus c. So you see how this method is a little bit faster, right?
Quick question in the, do you know these arrows, the 3 arrows? So the first one is negative 1 over 4. Second is positive 1 over 16 or negative?
Negative.
And the third one is positive, right? 1 over 64 is positive, right?
Right.
Okay, thank you. It's very clear.
Right. All right, so that's it for 8.2. Do you guys have any questions on integration by parts?
No, should be good. I think they can understand everything right now.
Okay. All right, let's see where we're at on the schedule. This is week 7. All right. So yeah, we should do. All right.
Professor,
Mhm.
Professor, if you still not feeling good, so you don't have to give us the whole 2 hours today. If you feel sick, we good. We can continue next time. Don't overwhelm yourself.
Appreciate that, man. I think I'll wait and see how I feel Wednesday. 'Cause right now I'm okay, but if I get worse Wednesday, I might just leave you guys a video or something. Okay.
Okay.
So I'll save that for when I know for sure I can't make it. All right, so let's keep on going. We're gonna do trigonometric integrals. So in this section, you're gonna have really weird trig problems. So you need to remember all your pre-cal stuff. Trigonometric. All right. You guys remember your pre-cal?
Wow.
Been a while.
Yeah. Jeez.
Let me give you the techniques, I guess. So if you have a sine to the power m, let me see where I'm at. Yeah, here we go. Times a cosine to the power n dx, and you also have integral of secant m x tangent n x dx, where m and n are positive integers. So these are identities you're going to need. So note, from pre-cal, you need to remember sine squared x plus cosine squared x is 1. You need to know the tangent version. Tangent squared plus 1 is secant squared. You need to know the power reducing formulas. Sine squared x is equal to 1 minus cosine 2x over 2. Cosine squared x is equal to 1 plus cosine 2x over 2. You guys remember these? They're finally useful. Well, at least these two. These two we didn't use that much in pre-cal. This we use all the time. But now this will be helpful because integrating this might suck. But integrating this one, it's probably easy. See what I mean? So that might be helpful later. Here are the rules for sine m, cosine m. Sine m x, cosine n x. So if m is odd, kick out. Oh, I should just say factor out. It's better. Factor out a sine x to save for du and convert the rest of the sines into cosines. And let u equal cosine. One second. Okay. If n is odd, factor out a cosine x to save for du. Convert the rest of the cosines to sines. And let u equal sine x. If m and n are both even, convert to odd powers of cosine using the half angle also called power reducing. Identities and proceed. So this is basically the strategy on how to solve these kinds of problems. I'm trying to get it all together for you. Okay, so if you have sine cubed, right, and cosine, I don't know, to the first, then you're going to have this scenario. Okay. So depending on what's going on, we'll use these techniques. If they're both even, then we'll just reduce the powers and not worry about it. Okay. So let's see here. Let's take a short break and then we'll start some examples. It's almost 9. You just come back at 9:10. So this is how you use it. So, for example, suppose you have sine cubed x cosine fourth x dx. So note that's a shitty ass n. Okay. So that is, so note that m is odd. So we're going to factor out a sine and convert it all into cosines. You're using that first one. So factor a sine, just one sine, and convert the rest convert the rest to cosine. Okay, this is what I mean. I'm going to pull out a sine so I can force it to be a sine squared. And then we use that Pythagorean identity because sine squared is equal to 1 minus cosine squared, right? This becomes 1 minus cosine. So then we need to distribute the sine and cosine. Yeah. So we get sine x minus sine x cosine squared x times cosine 4x dx. Distribute the cosine, and we end up with sine x cosine 4th x minus dx minus, I'm going to go ahead and separate, sine x cosine 6. Okay. So notice we can separate and create two separate integrals, right? This right here is a simple u sub, and so is this one. So you let, for both of them actually, you let u equal sine, cosine, and du will equal negative sine x dx. So negative du is equal to sine x dx. One second. Okay. So you see why we set this up this way, right? Because we'll have u to the 4th, because that's cosine, right? Du. So sine x dx is negative du. Okay, minus the integral of u to the 6th negative du, which will be negative u4 du plus integral of u6 du. Now these are easy integrals, right, at this point? This will be negative u5 over 5 plus u7 over 7, right? Put our c there, bring back cosine, and we have negative cosine to the 5th power plus cosine 7x over 7. Is there any questions about any of those steps? That's not too bad. Makes sense.
Oh, I was ask a quick question. Why'd you put u for cosine of x?
So the reason I chose that was because the u and du would exist, right? Because u is cosine, so that would handle the big power. Du would be sine, so that would take care of it. So I can jump easily to a basic power rule. But Taylor chills in the other way, right? I would not be able to do it. If u is sine, I can't put du to the 6, so it doesn't make sense.
Okay, thank you.
Where do we get the exponent 6? Have we taken from the cosine, or we're adding the? Oh, okay, I see it from the cosine.
This distribution, right?
I see it now.
Cool. Yeah, the idea is you want to pick u where the du is there. So I chose u for cosine because du is right. This easy basic one here. Once we do the sub, then we get there. So that's the idea. You're trying to rig the question to create an easy u sub, okay? Because or just something you can integrate a lot easier. Let's do another one. Cosine cubed x over square root sine x dx. Okay. So right now there is no sub that can help you. So let's see if we can rewrite this and then maybe use one of those factoring ideas. One moment. Okay. So currently I cannot do u to u, right? So note that n is odd. So factor a cosine. Okay. So cosine would be pulled out, and then we deal with the cosine squared. Okay, so we will change this into 1 minus sine squared. We will try the same thing again and FOIL it out and see if we can do a u sub. See if this helped us. So we get cosine x minus cosine x sine squared x times the 1/2 nonsense. See if this works. We will get cosine x sine negative half x minus cosine x sine squared times sine negative half will be 3/2 x dx. Right? Okay. So we'll separate these into two integrals. Sine negative half cosine x. I'm going to rewrite it just for fun. Minus sine 3/2 x cosine x dx. What do you guys think u should be? Now we can do u sub. And there's some extra notes here for you. You guys forgot, right? You want to get rid of the hard stuff and make sure the du is there, right? So sine will be the u, du will be cosine, right? So this will be u to negative half du minus u to the 3/2 du. So now that's something you guys have done before, right? Then you grow this guy, that'll be 2u to the 1/2 minus, and then that would be what, 2/5 u to the 5/2 plus c, which will be 2 square root sine minus 2/5 sine to the 5/2. You can leave it as half, I guess, instead of being weird. Doesn't matter. Okay. Is there any steps that don't make sense? Okay. You guys cool on this one then? If not, let me know. What do you guys think we should do?
We're gonna
Cosine.
have to use the power reducing identity.
Yeah, I think that'll be the best bet. Because we don't have a sign, so we can just reduce the power until it's low enough to do basic integrals, right? So remember, cosine squared x is equal to 1 plus cosine 2x over 2. Sine squared x is equal to 1 minus cosine 2x over 2. So we will do is algebra and pre-cal before we do any integration. Do you agree that this is the same, right? Cosine squared squared. So the inside will become this guy, 1 plus cosine 2x over 2 squared. Then you have to FOIL this, which will be 1 plus 2 cosine 2x plus cosine squared 2x over 4 dx. Right? When you FOIL this guy. So here to here, we did power reducing. Here to here, we just did some algebra. But these are pieces that we can integrate separately, right? So technically what we can do, we'll pull out the fourth outside of everything just because if I don't have to deal with a fraction, I'm not going to do it. So this is the 1. This is the 2 cosine 2x. And this is the cosine squared 2x dx. So the first one is no big deal. That's just x, right? That'd be x over 4 plus integral of this guy. Remember I showed you that formula? That'll be sine 2x divided by 2. So that'll be sine 2x. Because that 2 will cancel. Plus this guy, do another power reducing. So that would become 1 plus cosine 4x over 2. Oh, shit. I distribute the fourth already. So I'm going to go ahead and put the fourth out here. There we go. So 1/4 times a half, that will be the integral of 1/8. Let's pull it out. Of 1 plus cosine 4x. I guess I didn't need that step, but whatever. It's done. Now the integral of that will be 1/8 x plus 1/4 sine of 4x plus c. The final answer will be, you combine the 1/4 x and 1/8 x, right? That will be 3/8. These I cannot combine, so that's it. So that's the end. Is there any steps that you missed if I went too fast? Beginning or end? Do you have any questions? This is a 3, by the way. Okay.
Well,
So let me give you the rules for secant tangent. But the setup will be the same. Like pretty much the technique is almost the same. So I'm going to go ahead and write it down just in case you forget. Secant mx tangent nx. Okay, here's the three little, whatever rows, 4 rows. If m is odd, factor out a secant tangent x for du and convert the rest to tangent. Let u equal secant. If n is even, kick out, or sorry.
Let 4 equal what?
Let u
U equal what?
secant x. All right. If n is even, factor out a secant squared x for du and convert the rest of the secants to tangent. Let u equal tan. If no secants are available, if no secants, factor out a tan squared, then convert it to secant. Let's see, let me write it the other way, secant squared. Then let u equal tan. If no tangents integrate by parts, they just use integration by parts. Don't even worry about it. 5. If none of the above applies, convert everything to sines and cosines. Yeah, I think it's time for one more here.
Is that
Sorry?
number 4 is if no tangent, what does that work? Integrate.
Integrate by parts. Yeah, so if you don't have any tangents when you start and you just see secant by itself, and it doesn't, and it's not like one of these, like if it's not number 2, and you have a secant, you have to do by parts.
Okay.
Like a regular secant, like secant x. Integrating secant x, the only way is by parts. And it's pretty long too. And the last one is that if none of the above applies, convert everything to sine and cosine. But let's do one example, and we'll call it a night because we're almost out of time. And I think, Mohammed, you had a question. I'll try to send it to you tomorrow early, okay?
Okay.
I haven't forgotten. Okay, so tangent cubed x over square root secant x. So it looks like m is even. So factor a secant tan. Okay. Let's bring that secant up first. All right.
Secant x tangent.
Mm-hmm. Yeah, hold on. Let me do something first. So it's as if the note says factor secant tangent, but there is no secant up there, is there? Right. So what we're going to do is introduce a secant, top and bottom. You can still do this stuff if you want. So now I have secant x tangent cubed x over secant to the 3/2 x dx. So then I can factor, as the note said, secant x tangent x tangent squared x dx. Secant 3/2 x. Then the note said, right? The note said factor out secant tan for, because we're going to use that for du later, and convert the rest to tangent. So I want everything as tangent. That way u will be tan and du will be secant tan. Okay. But we still got to deal with that secant at the bottom. So we're almost there. Okay. So this will be secant x tangent x times 1 minus, no, sorry. Secant squared minus 1 is tangent squared. Right? Secant squared x minus 1 dx over this nonsense. Okay, so then, okay. So then I'm gonna do this. Remember, I'm saving the secant tangent for the u sub, so I don't want to mess this up. So I'm gonna move it to the side. I'm gonna bring up the secant. And I'm saving this guy over here for later. This is gonna be du eventually when I'm ready. Maybe we are ready. I think we're good actually. Yeah, check it out. So let u equal secant. What is du? What's the derivative of secant?
Secant x into 10x.
Right? Yeah, secant x, tangent x. So that's what we needed. So we have the integral of u squared minus 1, u to the 3 halves negative, du. Now we can integrate that, no problem, right? Integral of u to the 1 half minus u to the negative 3 halves du. After you distribute, right? You get here. Now, basic power rules, this would become what? 2/3 u 3 halves minus 2, actually plus u negative half plus c, which will be 2/3 secant 3 halves x plus 2 secant negative 1 half x plus c. Yeah. This is good enough for me. I'm not going to go do algebra on this. It's fine. Because you could make it a little bit prettier, but screw that, right? It's not necessary. Anyway, do you see the idea here, right? We're trying to set it up so we can do easy subs, but it requires us to be comfortable with our trig and the identities. You guys have any questions on 8.3? All right, so chapter 8 has 3 main integration techniques, I believe. Let me see. Yeah, 1, 2, 3. 3 main ones. This one is more like I don't really call this a technique. This is more like how do you use trig to help you out, right? But by parts is the new integration technique. So now you have u sub as your first one. Well, the first one I guess is the power rule, the basic one. And then you did the u subs as 2. And then tomorrow we will do a new one called trig substitution. This one is a little harder because you have to remember your more trig, basically. So the next one is a real technique. Okay. Anyway, so we'll stop here. I recommend practicing with your trig and doing the homework a bunch of times so you can remember if you forgot. And then we'll continue the next technique tomorrow or Wednesday.